Hello, welcome to Introduction to Sequences. Exercise 13, Chapter 2, Sequences. Toothpick problem. If you have enough toothpicks, you can make a large triangular grid. The size 1 grid requires 3 toothpicks. Size 2 grid requires 9 toothpicks. Draw the triangular grid of size 3. For part A, we are asked to write out the first 5 terms of the sequence. For part B, we are asked to find a recursive definition. For part C, we are asked to define the sequence as arithmetic or geometric. And for part D, we are asked to find a closed formula. So, we are given 3 toothpicks. With 3 toothpicks, we can draw one size 1 grid. So 1, 2, 3. With no toothpicks, we can draw size 2 grid, and we draw size 3 grid with 18 toothpicks, and we can continue. For size 4 grid, we will need 30 toothpicks, and size 5 grid, we will need 45 toothpicks. This way we can see our sequence is 3, 9, 18, 30, 45. A1 equals 3, A sub 2 equal 9, A sub 3 equal 18, A sub 4 equal 30, A sub 5 equal 45. So we have our 5 first terms of the sequence. Next, so to find this sequence of first differences, we will subtract 3 from 9, 9 from 18, 18 from 30, 30 from 45, and we get 6, 9, 12, 15. To find a sequence of second differences, we will subtract 6 from 9, 9 from 12, 12 from 15, and we get sequence of 3s, 3, 3, 3, 3, constant. So this way, we can write recursive definition. A sub n equal A sub n minus 1 plus 3 constant times n, with A sub 1 equal 3, because we are given 3 toothpicks at the beginning. So we have a bunch of these 3, 3, 3 differences, and we can find A sub 4, A sub 5, A sub 6, and so on. Part C. For part C, we are asked to find closed formula. No, for part C, we are asked to, writing the triangular numbers like this helps to see that the first sequence is the sequence of partial sums of the second sequence, and if we know how to add up the terms of an arithmetic sequence, we could use this to find a closed formula for a sequence whose differences are the terms of that arithmetic sequence. So the sequence is of partial sums with common difference d equal 3. So sequence 3, 6, 9, 12, 15. For part D, we are asked to find a closed formula. So we want to find the formula for the partial sums, and it will be the same formula we can use for a sub n to generate the terms in the original sequence. So we call sum as equal 3, 6 plus 9 plus 12 plus 15 plus plus 3n the last term, and one last term, it will be 3n minus 3. We use reverse and add technique. We reverse the sum, so 3n become here, and 3 will be last here. So we add two line term by term, and we get 2s equal 3 plus 3n plus 3 plus 3n plus plus 3 plus 3n. So bunch of 3 plus 3n, and then so n numbers we multiply n times 3n plus 3, and we got our formula 2n equal n 3 plus 3n, divide both sides by 2, and we got closed formula a sub n equal n times 3 plus 3n, all divided by 2. So to wrap up, we got size 3 grid with 18 toothpicks. We got 5 first terms as asked. We got recursive definition an equal an minus 1 plus 3n with a sub 1 equal 3. We defined the sequence as partial sums with common difference d equal 3, and we find out the formula, closed formula a sub n equal n times 3 plus 3n all over 2. Thank you.